Okay, so last video we kind of learned about the very basics of electricity and talked a little bit about static electricity. But on this one, we're going to dig in a little bit more with current electricity and circuits. And I just also want to say if you hear like a snoring sound in the background, it's because my dog, Luca, is asleep like right next to me. So anyways, let's move on. So a circuit. The first thing we need to think about with circuit is what does the word actually mean? And so I want you to look at these first four letters here, C-I-R-C. What word comes to mind when you see those four letters? Okay, so you maybe said something like circus or circumnavigate or circumvent or maybe just circle, which is the root for all those words. And so circle, we all know what a circle is. Is just it goes around the outside and it's connected. That's the main idea we want to keep in mind here. The outside is all connected, and that's what we'll see in our circuits today. So here's a basic example of a circuit, and you'll notice that it doesn't really look anything like a circle. In fact, it's a rectangle. But you know what? We still call it a circuit just because, like I said, it's connected all the way around. That little red dot is showing us that it can go all the way around and it's connected. This would be a pretty simple example of a circuit. We could certainly have much more complicated examples of circuits like this one over here. Again, this doesn't look anything like a circle, but there is sort of a one continuous path all the way around the outside, or in this case, there's actually lots of continuous paths, but the point is that they're continuous. We will be doing much simpler circuits than this one here, but maybe a little bit more complicated than this one. So let's talk about some of the parts that you will see in a circuit. So if you don't have a voltage source, it's going to be a pretty boring circuit. So that's a pretty good place to start. And you remember, voltage is a way of measuring basically how much energy is in our electricity. And so our voltage source is going to be what's providing that energy. And we have a couple different kinds we're going to worry about. The first one, there we go, is called is for a DC circuit or for direct current. And when we see one of these in a circuit, it will look kind of like this, where it's going to have the wire comes in on one side, and then there's a little short line, and then a long line, and then the wire comes out the other side. And that's basically just the symbol that we use for something like a battery. Sometimes you'll see it with more lines than this, maybe 4 lines, but it means the same thing. So if we have direct current, that's DC, there's also kind of the other version, which would be alternating current, or AC. And AC, the symbol looks kind of like this. Again, the wire comes in, then we got a little circle, and the wire comes out the other side, and in the middle we got this little sine wave thing. And you'll see both of these look the same, but they have a difference up top, and that is that one says 40 hertz and one says 120 hertz. And we'll talk more about that in a minute, but just so you know, wall outlets in your house are AC. They're alternating current. So let's talk a little bit about AC. We're actually going to spend most of our time talking about DC, but I want to talk about AC before we move on. So hertz, I mentioned that a second ago. That's just a unit that means how many times per second. And it's just a way of measuring how quickly something happens, or the frequency. And that's maybe a word that you've seen before. And so if I say something has 40 hertz, that means it happens 40 times per second. And so, per second, that's pretty quick, right? So we're talking about things that are happening quickly here. And electricity is a good example. And so I mentioned that your wall outlet has AC. So in the US, wall outlets are 60 hertz, which means that the current flips back and forth between positive and negative 60 times every second. And to help visualize this a little bit, I've got a little simulation. We're going to play around with this simulation later, but I wanted to show it to you right now. So if you look up top, I've got a very simple circuit with a 40 hertz AC voltage source. And down here, I have almost the exact same circuit, except this time it's 120 hertz. And I want you to look at these two little circuits that I made. And you see how the yellow dots are moving forward and then they're moving backward. and they go forward again, and they move backward. So that's what I mean when I say alternating current. It's switching back and forth between going one way and going the other way. And if you look at these, which one of these is switching back and forth faster, the top one or the bottom one? Yeah, so the bottom one's moving about 3 times as fast, right? And that makes sense because 120 hertz is about 3 times 40 hertz. Okay, so that's how AC works. We will talk maybe a little bit more about AC later, but for right now, we're going to kind of focus on DC. So the next thing we need to worry about, you actually just saw an example of this, is a resistor. And remember, resistors sort of resist electricity flowing through them. That's why we call them resistors. And we measure resistance in ohms. Hopefully you remember that from the last video. And one other thing, usually we're not really ever going to be dealing with like 3 ohms, 5 ohms, 25 ohms. It's going to be in the hundreds or in the thousands even. And so to save us some time and space from writing thousands and lots of zeros, we just use a K to represent 1,000. So 1K means 1,000, in this case, ohms. The higher the number, the more resistance. So let's take this 1K resistor here. This means it has 1,000 ohms of resistance. You might not really have any idea what that really means, but we got to start somewhere, right? So next, let's look at this one. This one says it has 5K or 5,000 ohms resistance. So which one of these two, the 1K or the 5K, would have more resistance? Yeah, it's pretty easy, right? The bigger number here, 5 is bigger than 1, so this one has more resistance. Well, what about this one? This one says 500. So between our first one, the 1K, and the third one, the 500, which one of these has more resistance? So you might have been tempted to say this one because 500 is in fact a bigger number than 1 up here, right? 500 is definitely bigger than 1. But 500 is actually smaller than 1,000. So remember, the K means 1,000. So in this case, actually, 500 is the smaller one. All right, what about between the second two? If I have 5K versus 500, well, yeah, 5K is bigger than 1K, and 1K is bigger than 500. Then 500 is still the smallest, right? So my point here is don't let the K confuse you. The K just means 1,000. The more ohms, the higher the number, the more ohms, the more resistance. Okay. So last of all, we're going to talk about switches. And so switches are just a way to help us control how current is flowing through our circuit. And so we have 2 different types we're going to worry about today. A single pole, single throw switch. And it sounds a lot more complicated than it is. It's basically an on-off switch. If it's like this, the current can flow through, kind of how my little mouse is going through there. So this is, the current can flow through this. The current cannot flow through this, right? This is not a clear path. Like it gets to here and it's like, oh, I can't go any further. So this current is not flowing. This would be off, and this one would be on. We call it single pole because there's one pole there. Single throw because there's only one place it can be. It's either here or off. For our other type, a single pole double throw, we're still going to have a single pole, so one little path for the current to go, but we can change it. There's 2 or double places that it could go. On this one, it could go on the top path, or it could go on the bottom path. And again, to help you kind of see how these work in a system here, I made another little circuit on my little program here. So right now we can see we have a DC current source. My current is flowing through this little 250 ohm resistor, flowing along, no big deal, right? No problem. Well, what do you think is going to happen if I click here and I open this switch? Yeah, so the current stopped, right? I said, all right, you can't go this way anymore. I'm closing this path off. Okay, so if I close it, the current should start flowing again. Good, there it goes. What do you think is going to happen if I change this? So this is our single pole, single throw. This is our single pole double throw. So what's going to happen if I put it the other way? Yeah, so the current keeps going, but what do you notice? What's different about now? Well, let's say this is situation 1, our 1,000 ohm pathway. what's different between that and my 250 ohm pathway? So hopefully you notice that the 250, the current is flowing a lot faster. When I make it go through the 1000, it slows down a lot. And so that kind of makes sense. We said a higher number, so 1000 is higher than 250. 1000 has more resistance, so the current goes slower. Okay, so that's kind of a basic introduction to electric circuits. My plan is to give you guys an assignment and let you play around with this little app that I'm using right here. It's free and you can get on it with your computer. And I'll give you some different little challenges to build with your on here, and I'll give you instructions on how to do all that. But that will be another video. So good job on this one, and I'll see you next time.